Hey, this is XDF, and today we're looking at the Sans Holiday Hack Challenge 2022. And we're looking specifically at the web ring and at four forensics-like challenges they give us that involve a PCAP file and a web log file. So kind of forensic-y challenges. I'm going to group them together. Let's start by looking at these challenges. There's naughty IP, credential mining, 404, FTW, and IMDS, XXE, and other abbreviations. We'll come to these one by one, but we'll start with naughty IP. So use the artifacts and analyze the attack. Most of the traffic seems to be nice, but one IP is being naughty. Which is it? So let's go ahead and take a look. I got the PCAP open here. I haven't done anything else to it. When I do a PCAP, I always want to start with coming in here looking at some of these statistics. So conversations is a really nice one to look at. And this is going to give me, in the IP tab, for example, we're going to get everything that is between two endpoints, two IP addresses. So we can see 10, 12, 42, 16 is in a lot of these. It makes sense that you might be seeing that if we're recording that PCAP from our server. So all the traffic is going to and from our server, and that probably is it. And then all the rest of this is traffic, even here where the address A is 10, all the rest of that is just go to that. We can jump over the TCP tab and see now it's split out by port and host combination. So it's actually got four pieces. And so that's why we see like this 315 has a lot of conversations with port 80 on our server. But that's just because each time it connects to the server, it's going to use a different random high port. And so these ports, you can see these ports changing, actually going up by 2, it looks like. But these are all conversations with port 80. So we think we've identified, okay, 10, 12, 42, 16 is a web server. And it is serving to a bunch of other people. Let's see, is port B ever not a web server? So there are a few in here, but not, the vast majority of this is just web. So sorry about the font on this. You might have to just do some squinting because I don't think I can make this bigger. Coming back over here, we can look and say like, well, who's having the most conversation with our server? And that is this 18, 222, 86, 32. Now, does a lot of conversation necessarily mean bad? No, but it's a good place to, it's kind of suspicious. But it could just be a really interested user. But especially in a CTF like this, it's suspicious for sure. We'd want to check that out. Let's see what the other thing that's useful, and we'll leave this open. We can come over here and we can say, go to statistics and protocol hierarchy. We can look at kind of what kind of traffic are we detecting. So all of the traffic is Ethernet, is IPv4, it's TCP. Then we see the only thing it really identifies is HTTP. And then we've got line-based text data, HTML form encoded data, and XML. These are kind of interesting. I'm particularly interested in form data because that's always like a login and things like that, things that get attacked. So I'm going to apply this as a filter. And if we come over here, now we can see on our form data here, let's see, make this big enough that we can see it. Full screen. Come here, and we have our form data. And we can see right now we have a username and a password. In this case, Alice and Philip is the password. And we can start to scroll through here. We can see Alice and Olas, Alice and Marilyn, Alice and Buttons, Alice and Roma. So somebody is clearly, and somebody being at the IP address 10.18.86.32, is clearly guessing passwords here. We could check and see if these are being successful, but I'm going to tell you right now, they can't all be successful, right? Typically only one password is accepted unless something is really wrong. So this definitely seems like a password brute force. So I'm going to go ahead and say we've solved part 1 here, that we found our malicious IP. Before we, I guess one thing I'd be curious to know is does it ever succeed? And what I might want to do down here is come down to the very end and say, let's see. Oh, didn't mean to do that. Let's come down here. Make some of these smaller. I'm going to add, I don't know why it's not showing up here now. I'm going to add a couple extra columns to my, so we'll do edit column, not edit columns, cancel. Column preferences, and we're going to add new column. We'll call this TCP stream, and this will be a custom, and the field will be tcp.stream. Oops, tcp.stream like that. And I'm going to add another one here that we're going to call host. I'll make this custom as well. It's just http.host like that. Okay. And these are super useful columns to have if you have them. Where'd they go? Oh, here we go. Okay, so let's add this over here, and we will drag host here. Okay, so we can now start to see all of our posts are going to toteslogist.us, and we have our TCP stream. I'm going to move this over here to the kind of with my time and my number. Okay, so now we're looking down here and we're seeing all these posts going here. Let's go to the very bottom, and we can see it looks like 1614, 1615 up through 1619 are all sending posts as, oh, we changed names at some point. Ingrid in here. And then there's a gap here. So we have the time, let's see, about 30-second gap after all of these are in the same second. And then we log in as Bob. Let's check these out. I'm guessing we can sort of feel like up to here. We can do a TCP stream here. I'm going to remember 1811 is a stream. We can look and see. So here you can see it says invalid username or password. Same thing on this one. Same thing on this one. And then we can jump up to TCP. The Wireshark stream thing is very finicky about it. It wants to update every time you put a character in. So we're going to do 1811. We can see when we log in with Bob and password with a 0, we actually get a redirect and it sets a cookie. So this actually seems to be working. We could actually take this cookie, look at JWT, and we could open up Firefox and go to jwt.io. Oops. Let's try that again. Without burp on. jwt.io. And we can see, paste this in, we actually have a cookie as Bob here as admin level. So that looks like a successful login. Okay, so we've definitely solved the past question here. We know the bad thing. Let's real quick before we go. Let's see how we would have seen this in the weblogs. So we can do vim weblog.error, and we can sort of see there's just a bunch of stuff in here. One thing I'd be curious to look at again is like which IP is talking the most. So we could do cat weblog.error into grep. Oh no, let's not do grep. Let's do cut because it was the first field. Let's take a look. It's the first field and it's space separated here. So we're going to do into grep into cut minus the D is space, and the first field is that. And so now we get this, which is just a bunch of IP addresses. There's some empty lines and stuff at the top. I'm going to add a grep dot for dot to get rid of those. I still have warning and press, but we'll just ignore those for now. So if I want to see a count of IP addresses, I will sort, and I will do a unique minus C, and then I'll sort minus NR. I don't know if I need the less anymore, but so now you can see here's our suspect IP address again, having way more logs than basically anything else. Again, volume is not specifically bad, but we can take a look at their activity. So we can do get rid of a lot of this stuff. Oh shoot, I don't have the IP address anymore. 18.222, is that it? 18.222. Let's hope this is it. Grab this, copy. Actually, you know what we better do? Let's just go up and run that again, and here we go. Now we've got the IP address, so we can do, in fact, let's just do this so we have it on the screen. We can do cat weblog.error. I realize you can grep straight from there. I've just always been in the habit of catting, so that's what we're gonna do. It's gonna be a fixed string. It's gonna be that IP address, and we're gonna pipe that into less. And so here we're looking at just like, what is this guy doing, right? And so we can see here, there's some browsing, some get us, some getting login, blah, 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 trying to get admin, which returns a 302 redirect, probably sending it back to the login page. And then we just start seeing posts to login. And there's a bunch of posts to login. And then we start seeing GET requests. And now we're seeing GET requests, all sorts of stuff. And we're seeing GET requests that are returning 404, which means they're not found. These things don't exist. So this feels like a web brute force. I think I've actually just moved into the next question. So I'm going to pause it right here. Let's go here and see if we can do some question answering. So we have the IP address. Pop that in, and we get that right. Now, the first attack is a brute force login. Oh, we got that already. That was Alice. Remember, we saw that. Great. So the next attack is a force browsing where the naughty one is guessing URLs. We've seen that already. What's the first successful URL in this attack? Okay, so let's go back to our VM here. We're down here. We are guessing. I'm seeing just a ton of 404s. If we can just come down to the very bottom here, and we're going to see here is 200 on /proc. So that's actually going to be our answer right here. I guess we'll jump back over and solve that. That's proc, and that's happy. So the last one is the last step in this attack was it used XXE to get secret keys from the IMDS service. What URL did the attacker force the server to fetch? Okay, XXE is a XML entity injection attack. And basically what it does is it allows us to specify a variable in an XML payload and have it run some stuff and then fill that variable in such a way so we can read files, we can fetch web pages, etc. IMDS is the internal metadata service, I believe. It's an AWS thing. It's a API that exists on a specific IP. I believe it's 169.254.169.254 for AWS EC2 instances, and it allows you to fetch information about the service, the keys, etc. So it's a very common attack for things like a server-side request forgery or an XXE attack where you can read off of it. So let's jump over here and take a look. We have a bunch, once we get a successful find on /proc, all of a sudden we have these posts, looks like 6 or 7, let's see, 1, 2, 3, 4, 5, 7 post requests to /proc. So we're definitely going to want to take a look at the specific data there. Let's close these. I guess I could have went and got the XML, but we'll just do this. So a really handy filter I like to use in times like this is we can go say ip.idr equals, I think I still have it on my clipboard, yes, and HTTP request or HTTP response, like that. So now we'll just get these responses and these requests. We're still in the post logins. Here's our get. Let's go to the very bottom here, and we have, okay, so we have post to /proc coming here. So here's our get to /proc with a success. Here's our post to /proc, and we can now start to expand out and see what this looks like. Move this up a little bit. The product, let's expand this all out, duck.foo. Okay, so we have, this is a typical XML payload where you just have a product, it's a product ID, and then something. But then you're using this entity attack by creating a foo entity, which is, an ID entity, excuse me, which is going to use the system to call expect ID, which presumably would execute ID and then return it right in that value. Unfortunately, let's see, do we get a result? We don't. We get, the result just has product ID, it doesn't have anything in there. So let's try the next one. This time they're going to use the XXE system to call file on Etsy password. And again, it's going to just be inside this foo thing this time. And this time it seems to be working because we get back, well, clearly an Etsy password, right? So they've managed to read a file with the XXE. Now our question was the URL to the IMDS. So that's not this yet. Now it looks like they're actually using system to get icanhasip.com, which is going to return the IP address of the system, and we can see it show up right there. Stepping down to the next one. Okay, so here we go. Now we're using it to reach 169.254.169.254 latest metadata identity credentials, and what comes back is EC2. So we'll keep going. That didn't fetch a key. Now we're going to use at the EC2 one, we're going to fetch security credentials. So one of the things about this API is when you just try to get identity credentials, it's going to report back the folders or the paths that show up next. So that's how we're sort of walking this down. So now we're getting security credentials, and we get EC2 instance. And then this last one, I'm guessing we're going to get EC2 instance, and the result will be the credentials themselves. So here's the stuff. So let's go back up here. We need to get this URL right here. Can I copy this? Copy value. Come here and do a vim. Let's trim that down a little bit. The exciting part of the video where I clean up text. Great. grab this. They want the full URL, I think. And we'll come back over here, paste that in, and we've solved it. So a neat little challenge where we walk through some web logs and a PCAP, and we find several attacks. So thanks for sticking around with me, and I'll talk to you next time.